Let's supercharge our bot. I'm going to teach you how to record our in-game actions and run them again later. I'm Ben, and welcome back to Learn Code by Gaming. In the previous video, we learned the very basics of PyAutoGUI and wrote our first botting script. If you haven't seen that video, there's a link in the description to the full series. In phase 2 here, I'm going to show you how we can automate the creation of your timing bot actions so we can start to build a bot that's capable of many different activities, and it won't take us an eternity to do it. To do this, we're going to install another Python module, pynput. I tested a couple different methods for capturing our input, and I found pynput to be the easiest. Pynput can also be used to generate mouse and keyboard inputs, just like PyAutoGUI, but we won't be using it for that here. We're just going to use it to capture input events, and we'll use PyAutoGUI to play them back later. And with that, let's hop back over to the code.
Okay, so at this point in the tutorial, you should find yourself docked at Earth Station. And what we're going to do today is we're going to automate the process of selling our goods here at Earth Station, buying the next set of trading products, and then we're going to fly that back to Loki Station, just like we did before. But instead of manually typing out all the commands for that, we're going to create a script that will record our inputs in the game, and then we'll make another script that will simply play back those inputs. And so this is going to greatly speed up our ability to create these scripts, and so we can eventually create a whole set of actions that our character can perform. So your character should begin here, docked at Earth Station. And if you look around, you'll notice that we don't have a NPC here that we can easily talk to like we did back at Loki Station. But we still need a consistent starting location. And the best spot I found was here in the main lobby. If you turn right by this Javier Domingo guy, you can kind of wedge yourself behind him against the wall. And then, just like before, chat with the character so that we get our character oriented correctly. And then this will be our new starting location here at Earth Station. All right, let's get started writing the code. Let's begin by just creating a new folder for this code. Recording bot, we'll call it. I don't want that to be inside the timing bot. I want that to be outside. There we go. And the first script we need to write will be the script that records our actions in the game. So I'm going to call this recorder. And then using our main script from before, I'm just going to steal this syntax for setting up our main function. All right. And then the first thing we need is we need to install pynput. So that's just going to be another simple pip install. It's pynput, so no I there on input. And it looks like it installed successfully. Yeah, I see pynput there. So now in our script we can, well, let's do a from pynput import, I think it's mouse and keyboard. Now what we want to do is we want to set up just a basic listener to figure out, if we can detect when the keyboard is receiving inputs. So I'll make a run listeners function here to contain the setup for listening to all these inputs. What we want to do is we want to collect the keyboard inputs until the script is stopped, till released, let's say. And then use a link to the documentation on how to do this. So let's go check that out. Okay, so I'm in the pynput documentation, monitoring the keyboard. And we're going to grab that section of code. So this will set up a simple keyboard listener, and the parameters in here, it expects two functions, a function on what we should do when a key is pressed, and another function on what we want to do when a key is released. So let's go ahead and write those functions. On press, on release. And then let's go back to that documentation just to get these simple on press and on release function definitions. So the main part here is when we press a key, we're just going to print out what key was pressed. If it was a letter from the alphabet, it's going to go through this first try statement. It's an alphanumeric key, so we can grab the character of it. But if it's a special key, we're just going to print the key itself. And then when it's released, we'll also print out the fact that it was released. And then also in the on release, it's going to detect if the key that was pressed was escape. That'll stop the listener, which will go ahead and stop this infinite loop that's listening for inputs. So let's go ahead and run this and see if it's working. Okay, so I had a little issue with my indentation there initially. Make sure you get the indentation right on your with statement. Let's try it again. Okay, you should see it down here in your terminal just running. And when we press the key on the keyboard, it should tell us what was pressed, and then when it was released. So if I hold E, what it'll do, triggers lots of presses and just released once. And then of course we're going to hit escape to stop our program. Okay, I'm also going to format these format strings to the mode that I prefer. And the next thing we need to do is we need to capture the mouse input somehow. So to do this, we're going to collect mouse input events. We'll need to manually start this listener. And then when we receive our escape statement through the keyboard, we'll need to manually stop it. Just make a mouse listener equals mouse dot listener. Then onClick is the name of the parameter here, and we'll create an onClick function handler for it. And then to start it is just mouse listener dot start. And then we also want to wait for that start process to finish before we bind the keyboard. Wait for the listener to become ready. Okay, so I didn't do a great job the first time explaining how the keyboard and mouse listeners work. This is probably the most complicated part of the code, so let me try to explain it again. So in our run listeners, where we have with keyboard listener as listener, this is essentially initializing this keyboard listener, and it's starting it, and then we're going to join it to the main thread. So listener is a subclass of thread, and thread is from the base Python threading library. And what join does is it joins it to the main thread. So the main thread is going to wait for this listener thread to finish before it continues. So threading is usually used to run multiple processes in parallel, but in our case, we just want to wait for our collection of the keyboard inputs to finish before we continue on with the main thread. So that's what this code is doing. Now, to add our mouse listener, you might be tempted to, look at the documentation here. We could also add this with mouse listener. Blow it. But the problem with this code is it's not going to initialize this listener and then join it to the main thread until we release the main thread from our keyboard listener. So it would just capture our keyboard inputs first, and then it would listen to our mouse inputs, and that's not what we want. We also don't care for the movement of the mouse or the scrolling of the mouse. We just want the on-click is really the only thing we're interested in. So instead, what we have to do is we have to start the mouse listener manually. And that example is also from the documentation. It says non-blocking fashion. We can create the mouse listener like this, and then we can manually start it. Then we can manually wait for it to become ready. And what this will do is it'll start our mouse listener in a separate thread from our keyboard listener, and they'll be running at the same time. And then when our keyboard listener stops, we'll need to manually stop our mouse listener as well. So that's what we're doing in our onRelease. When we detect that the escape key has been pressed, we're going to go ahead and stop our mouse listener before we stop our keyboard listener. And if you want a better understanding of how threads work, you might be interested in this documentation page for threading, the threading library in Python. And you can see this start that we're using. We're also using this join function, and you can read more about them there. Okay, and the next thing we need to do is create our onClick handler. OnClick. Let's look at the documentation for this again. So let's go to handling the mouse, monitoring the mouse. Let's grab their onClick. Okay, so you can see they're giving us the XY coordinates. They're also giving us what button was clicked. And this pressed. This pressed is a true-false Boolean flag. And when pressed is true, that's the click down event. And when it's false, that's the release click event. So we're actually only going to want to listen to the release event. So if not pressed, let's go ahead and print this. And we don't want to stop the listener in that case, because we're going to use the escape key still to stop it. So let's remove that part of the code. And then we don't need to check if it's released or not, because we know it's always going to be released. All right, and so the last thing we need to do is when they click the escape key, we want to stop the mouse listener as well as the keyboard listener. So we'll want to stop mouse listener. This will be stop keyboard listener. So the mouse listener dot, I believe it's listener. Nope. It's just mouse listener dot stop. We'll stop it. And then this will still work to return false to stop the keyboard listener. We could also raise an exception though, and that's just a little more clear to me what exactly is going on. So that'll be keyboard dot listener dot stop exception. But of course, mouse listener isn't defined here, and so if we want to get the mouse listener out of the run listeners function and be able to use it in onRelease, we'll need to make it a global variable. So let's just go ahead and do that. That'll keep it simple. So start with mouse listener is none. Make a note to declare mouse listener globally so that keyboard onRelease can stop it. And then when we go ahead and wherever we use that mouse listener, we need to make sure we use the global keyword so that we know we're referencing the global mouse listener variable. Now let's test this and see if we're capturing the mouse inputs as well as the keyboard inputs. So A still works, and then clicking is working too. Cool. I went ahead and updated our onClick print statement just a little bit so we can see what button we're clicking on and then where on the screen it's being clicked. Okay, so now we're able to detect whenever a keyboard key is pressed or a mouse button is clicked. The next thing we need to do is figure out what time those inputs occurred at. So we'll start with importing time. Now let's from time import time. And then we're going to be referencing the start time of our script all over the place. Let's just make that another global variable. Start time. Declare our start time globally so that the callback functions can reference it. Okay, so first we need to set our start time. And let's start it after our listeners have been initiated. So down in run listeners, I guess before we start the thread, let's set the start time. And then on our input listeners, instead of displaying the full timestamp, let's display it relative to when the script got started. So why don't we make another function for this? Put it here under main. I think I'll call it elapsed time. And that'll just give us the current time minus the start time. So global start time, return the current time minus the start time. So now in our event handlers, we can figure out exactly how long after the start of our script that input occurred. So let's go ahead and put that in the print statements. Okay, so now when we run it again, it should output not only what buttons we clicked, but when we click them. One thing to keep in mind is when you're testing your recorder, whatever you have selected when you type in, it's going to receive that input. So be careful if you have like your code selected and you push some letters, your code's going to get those letters too. So be careful there not to mess up your code by doing that. And another thing that might happen is if you have your terminal selected when you're making your test inputs with the keyboard, your terminal is actually going to collect those inputs, but they might not actually appear down here in your terminal until you click another letter, and when you do, you'll see something strange like this. And when this happens, if you try to run your terminal again, you could see this error, strange characters, command not found. And that just means that your terminal window captured those inputs. And so you should be careful to either create a new terminal window every time you run your program, or after you've captured some inputs and ended it, go ahead and just hit like backspace a few times to clear that out before you try running your recorder again. All right, now we're getting a click there 5 seconds after the start of the script. Press H, that was about 9 seconds after the start of our script, and so on. Perfect. So now I think it would be a good time to go back and fix that issue where if you hold down a key, it records multiple pressed events. So let's see that again real quick. Yeah, so remember if you press hold down E, you get lots of pressed events and just that single released event. So to correct for that, let's go ahead and make one more global variable. We'll keep the track of the unreleased keys just in a list. And so whenever we press down on a key, we'll add it to this list. And then once we release it, we'll pop it off the list. So down in onPress, let's make a note. We only want to record the first key press event until that key has been released. So if that key is in our unreleased keys list, again that's global, then we're just going to return. We're going to exit this function. Else, let's go ahead and add that unreleased key using the append method to the list. And then of course in onRelease, we need to remove those keys from the list once they're released. Mark key as no longer pressed. Global unreleased keys. Let's do a try catch here. Release keys dot remove the key. If we get a value error, then we'll go ahead and print out an error statement. All right, let's give it a try, see if that worked. So I'm holding down D, and perfect. We have the pressed about 4.5 seconds in, and then released at almost 6 seconds. And that's what we want. Okay, so we're almost done writing our recorder script. The next thing we want to do is remember when each one of these events occur, and we're going to save that to JSON and then just output that to a file. So let's create a simple list for storing all input events. And then let's write a function for recording those events. Record event. So we're going to give it an event type. That's key down, key up, or a click. We're also going to record the event time. For key down, we want to record what key was pressed. And then for the clicks, we want to record what button was clicked. So let's just call that button in general for both of those. And then for key clicks, we're also going to have an XY coordinate. So we'll call that POS for position. But of course, keyboard inputs won't have a position, so let's default that to none for them. So we're going to add this to the input events list. So we need to, once again, tell the compiler that that's a global variable. Input events dot append to add this new event. And formatting, let's make this a dictionary. So time will be the event time. The type will be the event type. The button will be the button. And the position will be the position. And then when we record one of these events, let's go ahead and also print out what happened. And then after we add the print statement here, we'll remove it from our event handlers. So here's the print statements I came up with. So if the event type is a click, then we're going to go ahead and print out everything, including the position. But if it's a keyboard input, we don't have a position, so it's a little simpler of a print statement. Now we can go down to our onPress function, and instead of printing out what happened, we can go ahead and record the event. So let's record event. For the event type, so this is onPress. I could just put like key down here. So let's go ahead and create like an enum for this. Call it event type. Key down. The event time, we'll just use elapsed time to get that. And then the key character. Get rid of our print statement. Of course, if it's not an alphanumeric key, we won't have the key character. So we'll keep this exception statement. And instead of passing over the character, we'll just pass over the key. And then let's go ahead and set up this enum now. I'm just going to make a class for it. So key down will just be the string key down. We'll do a key up. And then a click. Looks good to me. So on release, it's going to have very similar code to onPress. Of course, the event type is on key up instead of key down. And then on clicked, record event. This event type will be click. Still want the elapsed time. We'll just give it the whole button, and then for the position, give it the XY. Go ahead and delete that print statement. And then let's go ahead and run this now. Make sure we're still getting all of our print statements that we expect. Okay, I've got the keys down, key up, and the clicks. Perfect. So the next thing we want to do is we want to convert that to JSON. So we'll import JSON. And then inside of our main, let's first print out how long our total script ran for. So recording duration. Give it the elapsed time at this point. And this will be in seconds. Then let's output all of the input events that we recorded. Let's put them in JSON format. So JSON.dumps. That's going to take our list of input events, convert it to JSON, a JSON string, and so that JSON string is what we're going to print out. Let's run that. Okay, and we get this error type of button is not JSON serializable. So sometimes we're passing in to button here a button object that comes from pynput and not actual string. So we could just convert that button to a string, and that should solve that problem. Click a few things. All right, here we go. So we recorded for almost 3 seconds, and then here is the output of everything that we recorded. So you can see we got that click, we got that pressing A, pressing E, and then the escape key. So the final thing we need to do with our recorder is output our JSON to a file. That way we can read that file later when we want to run back our actions. So let's define a file name. Output file name. Call actions test 1 for now. And of course you could use like a command line input to get this file name. I'm just gonna hard code it in for now. That seems like a simple way to do it. And then we're gonna create this file inside of main, let's say, after everything's done running. So first thing we need is a path to the file that we want to output. Let's get the directory first, and then we can add the file name to it. Use os.path.dir name of the current file. I'm going to create a folder inside of this recording bot to hold all these output files. We also need to import OS. And then the full file path will be os path join. Let's join the current directory with the folder that we want to make. Let's call it recordings. And then finally, let's put the name of our file. So that'll be output file name. And then we want to add JSON extension to the end of it. Let's use a string format to do that. That looks all right. And before I forget, let's go ahead and create that recordings directory. Now we can open the file and write to it. So in Python, they would like you to use this with syntax. It's with open. Open that file path. Open it for writing. Now we can use JSON dumps to write right to that file. So take the input events and we'll put it to that out file. We can also format this a little nicer, which I think we should do, because once we record these files, you might want to actually go in and edit them sometimes just to make adjustments. So we can do indent equals 4, and instead of outputting the JSON all on a single line to this file, it'll now do a carriage return at the end of each line and do indentation for us. It'll make it look a little nicer. So finally, let's run that and see if we get a file output. Oh, file is not defined. I think that should be lowercase, huh? Let's try it again. Dumps only takes one positional argument. So it must be the output file. Okay, so I looked it up, and when you're using an output file, you don't use S. S is for string. It's just JSON dump, and then you can put it onto a file. Let's try one more time. Okay, no errors this time. Let's check our folder. And we do have a JSON file in there. And it looks like it has our button clicks, keyboard inputs, and all the times that they occurred at. So that's perfect. This is all we need. Now that we have these inputs recorded, we can then run these later. Okay, so for the playback, let's go ahead and make a new script for that. Call it playback.py. And then I'm going to go to our old timing bot. I'm going to use this as the starting point. I'm just going to copy it all, paste it in. We could delete all of these action functions. We're not going to need to report the mouse position. Delete those calls. We won't need any delay between the commands because we're just going to do it exactly how we recorded it. Initialization we'll keep the countdown timer. And you know, I don't think we'll even need hold key because we're just going to fire the PyAutoGUI key down and the key up as we're doing our playback. Okay, and for our playback, the first thing we're going to need to do is open our file and read it. So we're going to need to import OS to find the file, and then import JSON to parse it. Let's create a new function for this, call it playActions, and I think I'll pass in the name of the file that we want to run. So this is actions test 01.json. Then let's go ahead and write that function. What did I call it? playActions. I gave it the file name. So let's go ahead and open the file just like we did in our recorder script. So I'll go and steal that code because we're still going to want the same directory. We still want, well, instead of this output file name, we actually just want to use the file name we're given. And then we're not opening for reading or writing anymore, we're opening for reading, so that's R. And we know this is going to be a JSON file. And we don't want to dump it, we really want to load it into a variable. So we'll just call that variable data JSON.load for loading a file. And then let's just print out that data for now and see if we are opening it correctly. So I'll run that. We've got our countdown timer, so it's going to wait 10 seconds. And then there we go. It looks like it opened that file just fine, and it output everything for us. So inside our play actions, we don't want to just open the file and print it out. We want to actually do all the actions that are in the file. Let's add some comments here. Let's parse the JSON first. And then what we want to do is we want to loop over each action. So that would be for action in data. But thinking ahead here a little bit, I'm actually going to want to get 2 actions at a time, the current action and the next one, so that I can determine how long I should sleep in between each action. So let's go ahead and do an enumeration. So let's get the index as well as the action and enumerate on that data. So when we're looping over the actions, I guess the first thing we want to do is look for that escape input, because that means we want to exit. So let's look for escape input to exit. So if the action button is equal to key.escape, then we just want to break out of the loop. But if it's not an escape key, we just want to reperform that action. So let's perform the action. And how we do that is going to be different depending on what type of action it was. So if the action type, let's check the type. That's either going to be the key down or key up or click. So we'll check for a key down. That'll be one thing. If the type is key up, we'll do something different with PyAutoGUI. Or if it's a click. So to recreate a key down action with PyAutoGUI, that'll be just like we did before. PyAutoGUI has a key down function, and we just wanted to know what key to press down, and we have that in the button data. Same thing for the key up, PyAutoGUI key up. Give it the action in the button. And then for the click, PyAutoGUI wants, they want the X, the Y, and the duration. So the X we can get from action position, and that's a 2-item tuple there, so the X is in the 0 position. And the Y will be in the 1 position. 1 index of that tuple. And then for duration, we could just set it to something pretty quick. 1/4 second again sounds fine. Now, if we were to run this code right now, it would simply zip through each one of our inputs and not pause it all in between, which is definitely not what we want to do. What we want to do is we want to execute these actions at the same time that they were initially performed relative to when we started recording our script. So we'll need to sleep for some amount between each one of these inputs. And we can get that by looking at the next input that's coming up and seeing how long of time there is in between the current action and the next one. So in this part, we're going to be sleeping, then sleep until next action should occur. So first we need the next action. And that's just going to be the data. The current index would be the current action, but we want the one after that. But of course, if this is the last action, then this index plus 1 is going to throw an error. So let's just put a try except around that. Should be an index error, right? If that was the last action, then we don't need to sleep at all. So we can just, once again, break out of this loop. And so now that we have the next action, we can calculate how long we should sleep for. Let's call that elapsed time. And that's just going to be the next action time minus the current action time. Right, because if we clicked A at 5 seconds, but we release A at 10 seconds, then we want to wait for 5 seconds, so that would be 10 seconds here on the next action, 5 seconds here on the current action, 10 minus 5 is 5, and that should be the correct amount of time to wait. So we'll just sleep for that elapsed time. And just in case there's a chance that our recording will record these actions out of order, so I just want to check, make sure elapsed time is greater than 0. If it's less than 0, it's going to throw an exception. But let's just check it just in case. So if elapsed time is greater than or equal to 0, just go ahead and sleep. Else, let's print out an error. I changed my mind. Let's actually raise an exception. And we'll say unexpected action ordering. Okay, and that should be all it takes to play back our actions. But of course, we're going to want to be careful about this. Let's not just play back the actions that we just randomly made earlier. So let's go back to the game. See if I'm still here. Yeah, I'm still here, still in the starting location. Let's record some actions in the game. So I'll go back to my recorder, I'll run it, click on the game window, click inside the game. Let's just look around. Turn left, turn right. And then we can hit escape in the game. That'll end our recording. I'll just hit cancel on that dialog. So we have a new recording. And then let's go and run it. So it's going to give us our 10-second countdown. But I'm not going to focus on the game because I believe the first thing I did was click on that game window. Let's see if it clicks on it to get focus on it. Yeah, it does. Alright, and there my character is turning left and turning right, just playing back my actions that I took earlier. So that's perfect. Another thing to note here is we do have access to this JSON file. So if that initial couple of clicks makes you nervous, which it probably should, you can go in here and just easily remove these, delete those commands. You can even, if you want to, go down and delete the escape commands. That way it'll just go through each one of these actions, and when it's done with this key up on D, it'll just stop doing actions and end the script. So let's see if that still works too. So let's play it. It's giving me that 10-second. This time I do definitely want to select the window. We'll see if our character turns left and right. There he goes. Perfect. So I think now, even though we saw it behaving correctly when it played back the actions, let's go ahead and add some print statements just to make sure that it's absolutely doing what we expect. So when we perform the actions, let's also print out how long we're sleeping for. So we obviously need to do that before we actually do the sleep. Sleeping for elapsed time. And let's just run that same recording again, see if we get those print statements working. Okay, and there we go. We have the key down at A. Then we waited 1.3 seconds before we pulled up on A. Then in between A and D, we just had 0.3 of a second wait time. And then once we did a key down on D, 1.5 seconds, and then a key up. And once we did that, we were done. So that's exactly what we wanted to see. Now the next thing we need to consider is the special keys. Keys like Shift or Caps Lock. These aren't going to be exactly the same between PyAutoGUI and pynput. So when we call say key down or key up, and we give it that, if it looked like key.escape, PyAutoGUI is not going to know what that is. So let's go ahead and write a function to do that conversion for us. So what we want this to look like is we want to get a key is equal to convert key. We're going to give it the action, and then from this pynput action, we want to return a PyAutoGUI value. So once we have that key, we can do a key down on that key. We also want to report that same key. Do the same thing for key up. And we shouldn't need to do anything for click, because here we're just using the X and Y position, and that should convert fine. Those are just integers. And then to create our convert key function, it's going to be given the button from pynput. We really need to look at the documentation for both pynput and PyAutoGUI and compare them and make any translations that we need to so that they work together. So here are the links to those parts of the documentation. Let's go take a look so I can show you exactly what I'm talking about. So here in pynput, these are all the different keys that it expects for its button values. And for PyAutoGUI, down at the bottom here, here's the values that it expects when you give it to key down or key up. So we just need to do a simple conversion here. So let's make a cleaned key, and in most cases all we need to do is remove the key dot command or something, or key dot F1, and just make it into F1, and that'll line up just fine. So I'll line up with F1 over here. So something that looks like key dot F9 should return F9, but if the button is just W, that should return as W. So those will be strings already. So we can just take that button string, replace, anytime we see this key dot, just delete it. So that'll work in most cases if we just return that clean key, and then there's just a few instances where we do need to change the complete name of the key. So here I've gone through the documentation. I found all the instances where whatever pynput is using to refer to a certain key is different than what a PyAutoGUI uses. And so on the left here is the pynput value, like caps underscore lock, and the PyAutoGUI value for that is just caps lock, no underscore. So now that we have a map there, I can just check that map. So if cleaned key, now the key portion of this string has been removed. If that is in our map, I call that pynput special case map, then we want to return the special case map value for that cleaned key. But if it's not in this map, then we're just going to return whatever was created by deleting the key dot portion, and that should work just fine. And this is important for our bot because we are going to use the shift key when we're buying and selling our goods, and so we need to do that conversion correctly. So I'm just going to run it quickly, make sure everything still looks good. My recording, of course, doesn't have any shift inputs on it, so I'm mostly just checking to see if I introduced any syntax errors or something like that here. It looks like that finished fine. So I think our recorder and our playback scripts are in a pretty good spot right now. Let's try recording a longer action in the game and see how well it does. So get the recorder script ready. Let's just go out here to the platform. See if we can go to the center of the room here and record that. Alright, so I'm going to run the recorder. And I'm just going to run forward into the room. Turn around in a circle. Maybe go this way. Pretty good. Of course, escape to end my recording there. I'm going to edit these actions quite a bit, I think. Get rid of those escapes. Get rid of these last few button clicks. I don't want any of those. Get rid of those initial button clicks. All right. Let's go back to where we started here. And then run our playback. Okay, not too bad. Let's do a recording, I guess, from our starting spot. So we're in this little corner here. All ready to go. Run our recording. I guess I'll back up first. Kind of turn to the middle of the room. Go there, turn right. Yeah, I think that's a good initial recording. Okay, let's play it back and see if I get similar results. Oh, of course I need to get to my starting position. Well, I'm not going to do that on time. I'll use my handy fail-safe there, upper left-hand corner, to stop my script. Alright, back to the starting location. Let's run it. Okay, that was pretty good, but you may have noticed that it seems like each one of our actions lasted a little bit longer than what we actually recorded. It wasn't a perfect match. So I think this is happening because if you look at our code, not only, well, let's look at our initial code before. Go to hold key. Let's take a look at hold key. So before we were simply pressing down on the key, sleeping for a certain number of seconds, and then releasing up on it. But our playback function's a little more involved. So after we open the file and we start running through everything, there's a few checks we have to do before the key down and key up. We're also doing some calculations here to get the elapsed time. And all of that takes just a little bit of time, and I think that's adding just a little bit of extra milliseconds to each one of our actions. So what we could do is we could record how much time is happening in between each running each action. Let's try that out. Action start time, and then it's going to perform the action. It's going to do some calculations. Action end time. Let's print out that difference. Execution time. That'll be the action end time minus the action start time. Let's get an idea of how long it's taking to process each one of these input events. So if I turn to my starting location, there it is. Let's run the playback script. Oh, time is not defined. So from time, let's import sleep, and we'll import time. And we'll get back to the code where we're printing that out. And we'll try it again. So let's look at our results. And we're seeing pretty consistently here, the execution time is almost a full 1/10 of a second, which is definitely enough to throw off our script, especially when we're turning left and right. You know, that's pretty finicky. So why don't we go ahead and subtract that execution time from the amount of time that we're sleeping. So let me reorganize this code here a little bit. Let's first check if the elapsed time is less than 0. And if it is, then we'll raise this unexpected ordering error. Otherwise, let's adjust the elapsed time. Elapsed time, we're going to subtract the processing time, which is the action end time, which we don't have because it's not here. So we can just call time here, minus action start time. And then we'll end up sleeping for that amount of time. But of course, if we have a really quick, like key down, key up, this could potentially be negative again. So let's say if the elapsed time is less than 0, we'll go ahead and make it 0. Let's put our print statement back there so we can see how long we're going to be sleeping for between each action. And then I'm curious to see if this runs a little more true. Okay, I think that was a little more accurate to what I initially did, so I think that's a pretty good improvement there. So now our recorder and our playback scripts are in a pretty good place. I think the next step is just to record each little section of actions and then string them together and play them back and see if we can create this whole bot here. So why don't I create a bunch of different actions for that? So let's go to trader. I guess this is an Earth station. We might have lots of these. So Earth station, go to trader. Let's sleep in between each set of actions. Let's say 2 seconds. And then once we're at the trader, we want to do the trading. Do trading. And then we want to go back to our ship. And then the last thing we want to do is fly back to Loki station. So that'll be the final step in our recording. And when we go get on our ship, before we go to Loki station, remember we have that loading screen. I think we gave ourselves 10 seconds last time for that loading screen. So let's do that again. And we don't need to sleep at the end here because we'll just be done. So now I need to go create these 4 recordings. So I'll copy that first step and put it in the output file name of my recorder. Then in the game, I'll remember to go to my starting location, this guy over here. Okay, and then we'll make our first recording. So when you're making these recordings, you still kind of want to act like you did before. Don't make too many minor adjustments. You're more likely to be off with your bot. So it's better if you try to make as few long movements as possible. And you want to try to get into the middle of everything as best as you can. Oh man, I got stuck in that door. I guess that's alright. Try to go that way. Aim for that same spot as before. And then we'll stop our first recording here. I think I need to turn left a little bit to get that guy on my screen. Alright. So we should have a new recording. This go to trader one. I'm gonna go ahead and remove those initial click events. The escape event. And then let's play it back to see if it worked. I'll go ahead and comment out these other actions that we haven't recorded yet. Of course, I'll need to go back to my initial starting location. Let's see how we did. All right, that was perfect. Now, one of the good things about doing these recordings and having it go to a JSON file is that if I want to make any minor adjustments, I can go ahead and do that. So like I paused for quite a while after I made that, at that last step when I made that last turn towards the trader. So I can go ahead and just adjust the time here. So my last forward step was done at 34 seconds in. So let's make this A turn happen at 35 seconds. But you need to keep the down and the up relative to each other, of course. This is an easy calculation because they're both 39, so I can just change it both to 35, and that should be no problem. Alright, so our first recording is done. Now we can go and record the second step. This is where we're going to do the trading. So I'm changing the output file name here on the recorder. Again, you could create a command line argument to get the output file name if that's your preference. So I will start recording. And then in the game, I want to talk to this lister guy. I want to be careful to try to aim for the middle of these buttons. And then I'm going to hold shift and click for all of these. And I'm making sure to pause in between each one because it does take us a quarter second to move the mouse in between each step here. And I'm clicking on these empty slots even though we have nothing in them, because eventually we will have full trading cargo. And then when I take this step to move the inventory to the right, I don't want to click and drag because our recorder doesn't have the ability to record drags. So I'm going to have to just click on the arrow 1, 2, 3 times, and I'll go ahead and sell these other items. A little tedious this first time, but once we record it, we'll be able to play back these actions as much as we want, and we'll have a fully functional bot. Let's get this last row. Perfect. I'll just close, click done, and that is the end of that section. So now we should have our do trading JSON complete. I'll just open this up and remove the first couple clicks as usual. This gets a little tricky. Which ones were legitimate clicks and which ones weren't? I think it's these first two. I'll go ahead and cut them so I can paste them again later if I was wrong. Then I'll remove the escape from the end as usual. I guess since I'm doing this all the time, I could just not record these escapes as well. That would be a little smarter. And then we're now ready to play it back. Let's go back to our starting position. Kind of really messed up that one. I think maybe it's because there's so many players in this station right now. That can affect the load timing a little bit. Alright, that looked better. Didn't quite get the trade that time. Alright, so I've made a new script, or I should say I've made a new recording for doing the trading part of our script. So now I'm running it, and let's see if that does any better. Okay, I made it through at that time. So the third section of our recording is going to be going back to the ship. So once again, I'll just update the recorder to use that file name. Then I'll go ahead and start recording. Back in the game, I know I want to turn this way. Center of the room. Turn to the exit. Walk through there, alright. Turn left again. Go out the exit. Turn towards the ship. Exit the starbase. And that's perfect. Now I'm just going to edit that trip back to the ship. So once again, get rid of those clicks. Once again, get rid of the escape. I'm pretty confident that was a good recording. Now to test it, I could go back through the whole process again. If you're having difficulty on this particular section, you might just want to start from the trading position, run this through a few times. Yeah, I'm pretty confident that was good, so I'm just going to test it right back from our initial starting location. This section here, selling, might be a good candidate for adjusting those times a little bit to go through a little faster. And as you saw, I'm only selling 4 items there. I'm just trying to get that working first. But the final recording of this, I'll want to sell all 28 items in those slots. Remember to click the arrows and not try to drag that bar. Looks like it's getting back to the ship alright though. That looks pretty dead center. Perfect. Alright, last step. It's just to fly here from Earth Station back to Loki Station, and we can record right from this starting location. Copy over that new file name. Let's record it. So that's 1 click. 2 clicks I want to delete. And I'm going to open the navigation menu. Click on High Earth as center as I can get it. Click C to do the warp. Make sure to give it an extra second here just in case the warp does take a little longer sometimes. But next I'm going to click on entering the gate. Alright, still recording. Give it a second to get through the gate, and then I'll open the navigation map. click on Loki Station, C again to warp. Then all I need to do is dock back at Loki Station.
Sequence initiated.
And then you can escape your recording there. Alright, I'm just editing this JSON one more time to remove those first two clicks, remove the escapes. In the game, I am at Loki Station. And that should be it. In my recorder, I'm going to go ahead and set this back to my actions test 01, just so I don't accidentally record over what I just created. But everything looks good. I'm going to fly back to Earth Station manually and then try to run this whole script, see if it goes all the way through. Okay, I'm back at Earth Station. I'm going to get into our starting position. And before I run this script for the last time, just some housekeeping items. You'll notice in the recorder, when we are recording the events, for the button clicks, we are saving the type, which is just a click, but we're also saving the button, and that'll be like left or middle or right mouse button. And in our playbacks, we're just doing a basic click in PyAutoGUI, no right click or middle click supported. But if you're playing a game, if you're botting a game that needs that, I'll leave you to implement that part of the playback. Also, if you're developing this and your script crashes at any time, you might end up with some zombie Python processes. So you'll want to do Control-Alt-Delete, go to your task manager, and delete those. So let me show you what that looks like. I'll just run the recorder here. If I do a Control-Alt-Delete, in my task manager, if you scroll down, you should see something that says Python. Oh yeah, and I've got a bunch of them here. So you're going to go and end all these tasks. These are zombie processes that are just sitting in the background. You may see your system get a little sluggish with these things hanging about, so you'll definitely want to go and close them down. Alright, perfect. And then if you've missed anything in the recorder or the playback, I've updated the GitHub repository, so you can find the code there just in case you missed anything. And the link to the GitHub repo is in the description of the video. So let's play this back one more time, see if our entire script works.
Docking sequence initiated.
Alright, so that worked pretty flawlessly. So now you can see it'd be pretty easy to record actions for all kinds of stations. You could set up all kinds of trade routes relatively quickly just by playing through them once or twice yourself, making a few adjustments to those JSON files to get them just right. But yeah, this will greatly speed up your ability to create new bots.
Alright, good job keeping up with me through this part of the tutorial. To get more practice, I encourage you to use our new recording technique to recreate the first part of our trading route. After landing at Loki Station, return to our starting position, and then have your bot go to the trader, trade the set of alpha rads, buy the new manufacturing robots, head back to your ship, and then fly back to Earth Station. At that point, we'll almost have a fully automated trading loop. But of course, we still have this huge handicap of needing to manually walk to each of our starting locations at each station. Up to this point, our bot has been completely blind, ignoring all feedback from the game. Also, our bot is very fragile. It breaks whenever we don't begin at the perfect starting location, or something simple like a doorway takes longer to open than usual. In the next video, we'll attempt to solve this. I'll show you how to use PyAutoGUI's simple image recognition features to automatically orient our bot when we land at a station. I'll also show you how we can stop our bot when it gets off track. So you'll definitely want to join me in the next video where we'll complete our beginner trading bot.